My dear student, in my first session, I had discussed the important features of the collision theory, and I have also discussed the difference between the collision frequency and collision density or the collision rate. And that time, basically, I have taken a identical type of molecules, and with the help of this identical type of the molecules, I have determined the values of Z2. Sometimes we consider it as a collision rate if you refer the Ladler. If you refer the Alberti and Bawendi, it is collision density. And I also discussed about the collision frequency. And ultimately, I have solved the problem of this frequency factor. Okay. Today, what I will try to discuss, what are the limitations of that collision theory and how that collision theory is modified. And if you see the literature, because collision theory was discovered in the year of 1918, and of course in 1916 also one scientist published a paper. But when I searched the literature, I have seen that in the year of 1933, one scientist, I think V. Lemer, Lemer, in Journal of Chemical Physics, published a paper based on this modified collision theory. Now, before I start this modified collision theory, I must show you some of the results obtained using that collision theory. Now, I am using one very simple reaction. Carbon monoxide react with oxygen and formation of carbon dioxide and oxygen. This is my first reaction. And second reaction is NO2 react with carbon dioxide in formation of NO and carbon dioxide. Now you see that in collision theory, normal collision theory, I assume that the molecules are hard sphere. Hard sphere. But you see that if you see this carbon monoxide or NO2, it is a polyatomic molecules, and you know the chemistry that all the polyatomic molecules has different type of the structure. It is quite natural. So it is not spherical. It has certain structure, number one. Number two, I also discussed with you that there is a term that is called the E threshold. That is minimum amount of, or we generally calculate the kinetic energy, relative translational kinetic energy must be exceeds to that threshold energy. That is the crude approximation, I should say, because sometimes if you want to calculate the kinetic energy and if you compare with the threshold energy, I am not saying that collision theory is not correct. I just want to tell you some of the demerits of the collision theory. So sometimes what happens that kinetic energy may be higher than that threshold energy. So how collisions are possible? That is a valid question. Then something about the distribution of energy. Something about the distribution of energies. Now, when they have calculated this simple reaction, I am giving only one or two examples, that the value of A calculated with the help of simple collision theory, or that is approximately 3.5 to, I think, 10 to the power 9 per mole per second. But when they calculate with the help of collision diameter, the collision frequency, collision rate, that was approximately, I am taking 8.1 into 10 to the power 11. First point, why such type of difference between the theoretical value and experimental value? Second point is that when this carbon end, so there are two ends, one is carbon end, another is the oxygen end. It was observed that when this carbon end reacts with oxygen, there is a reaction. But suppose this oxygen ends hits this O2, there is no reaction. What does it mean? That means such type of orientation plays a very significant role. So in modified collision theory, we will consider that type of orientation. And you know that this orientation, whatever the orientation or the structure, depends upon some factors. Now if you know the spectroscopy, then you can understand that there may be some vibrational motion, there may be some translational motion, there may be some rotational motion. And while studying the collision theory, you will not find such type of translational motion or vibrational motion or the rotational motion. So that is some of the demerits of that collision theory. Now before I derive these things, another problem is that when they actually, what is the success of any theory? It is a Arrhenius equation or absolute reaction rate theory. The condition is that if this theory is ideal, so there must be a good agreement between the experimental value as well as the theoretical value. So you see, in first cases, if I just consider the frequency factors, there are more than 230 times difference. If you just compare with this, approximately 3.5 into 8.1 is more than, so it is approximately more than 200 times difference. Now similarly, when I see this this reaction, so the experimental rate constant, I have seen it is 1.5 into 10 to the power 2 dm cube, the same unit of the rate constant. And when it is the experimentally we calculate, so it is around 3.14, approximately 3.1 into 10 to the power 11. Oh my God! At 870, and here is, I think, energy of activation is, if I am not wrong, 50 kilojoule, like that, and very high temperature. So you can understand that it is almost 2 billion times difference. I am not saying that all the reactions are showing such type of abnormal behavior, but in a nutshell, you can write that there is not a very close agreement between the rate constant of theoretical as well as the experimental, number one. Number two, there is a difference between the frequency factor calculated using the collision theory, considering the collision diameter, collision rate, mean free path. There are so many things. Okay, so therefore a modification of collision theory is required. Okay, so let me now before I start this modification, I should write something about the dissimilar molecules. I will write only, I will not derive this complete equation directly. I will write this thing. So we have already seen that our rate is equal to, simple, collision rate exponential minus, we have already, yesterday, my first class, I have already seen this. In this such type of molecules, per cc per second. And we also calculate Z for similar molecules. We have seen that this is collision diameter. I have already seen pi kBt m. We have already seen these things, and of course we also calculate if there is 2 Na and Nb. Na, volume, that number density, and also we calculate then we substitute the value here, and then ultimately I told you that because sometimes when I write the observed rate constant, we have already seen that, of course, because this Na is cancelled with these things, and in order to convert the molecules into mole, we have already seen that I have used the Avogadro number. Now, what is the problem? In some books you will find that, because there must not be a confusion between the mole, molecules, molar volume and other things. So in some books it is small na, small nb, because I can write minus dn by dc. So how we calculate the Avogadro number? So this n, then 2 a square pi kBt m exponential minus a by rt. This is actually sometimes meter cube, or we can write it as a, if you see the old system, so that cc per mole per second, or dm cube, you can write like that. That unit is different. So that was the things, and we must use that Avogadro number here. Okay. But we have already solved all these things. But if there is different types of molecules, that I also told you. Again, it is an assumption. Line of center is very important. Line of center is very important. You know, line of center is very important. It's line of center, and then collision is also possible there. So, like that, you know, line of center, theta angle, you know, this, all this. That day I also told you under root of. I will not derive all these things. So for if it is a dissimilar type of molecules, exactly everything is same. What is the difference? Difference here is that we will use that this A, suppose this is A and this is B, so I can use that B. Collision cross section, because there are two, you know, line of centers is different. So just we simply, and second change is that in place of M, we will take the reduced mass. Reduced mass. You know this thing. 1 upon MA, because there are two different types of circle. 1 upon MB. And what is the difference there? That Z is equal to just what we do in pi d square, all these things. When you calculate the area, it is a cross section of this thing. So, like that, sigma square, you can write AB. H, KT. K is Boltzmann constant. U. Here is pi K, here is pi KT. I think just small changes. And the rest of the things are same. Na into Nb. And if I just replace these things, so it is, you have seen two different equation, one for similar or identical molecule, another is for dissimilar type of molecules. So almost it is same. It is actually Avogadro number. It is actually Avogadro number, and it is actually collision diameter, you know, collision cross section, because here there is 2, so I can write like that, A plus this of B, and rest thing. And if it is a dissimilar molecule, so there is a change in the reduced mass, and this is final formula of rate constant for the dissimilar type of molecules. Now what I am doing, now I will derive the modified collision theory, because when we studied large number of reactions, it was observed that there is a difference between observed rate constant and theoretically calculated rate constant. So therefore we have to modify the collision theory. So let me derive this modified collision theory. I am using simple equation A plus B C plus D, and it is, suppose it is K1 K2 plus 1. So rate or right, so K is equal to Z exponential minus E by R. So the modified collision theory is nothing. We have to introduce a additional factor rho, that is called the steric factor or probability factor. Probability factor. Probability factor. So what I can do? K1 K inverse 1. Now there are two reactions. For one it is Z1 E1 by RT. For this reaction rho 2 rho inverse 1 Z inverse 1 exponential inverse 1 by RT. So if I substitute here, so it will rho 1 Z1 exponential E1 by RT rho inverse 1 Z inverse 1. If I so K1 and K inverse 1 is equal to exponential minus E1 RT. It is actually delta E, you can write. And we know that this K1 and K inverse 1 is the equilibrium constant. And delta G is a very common reaction equation. Delta G is equal to minus RT natural log of equilibrium constant. So I can write natural log of K is equal to minus delta G by RT, or K is equal to exponential minus very simple. So I have to substitute the value of K in this equation. I have to substitute the value of k in this equation. So it is exponential minus delta g by RT is equal to now we all know that delta G is equal to delta H minus T delta S, which gives Helmholtz equation. And this is actually, this is free energy, standard free energy. This is enthalpy. And this is entropy. So if I substitute the value of delta G in this equation, I will get exponential minus delta H standard RT. Here is also minus, so minus plus exponential, this T is cancelled with this T, so delta S by R is equal to exponential minus RT. Now, the last part of this equation is suppose this enthalpy, change in enthalpy is comparable with this internal energy. What I can write? I can write E exponential delta S R is equal to that means there is a possibility also that sometime Z1 is equal to Z inverse 1. There is a possibility also. Or you can directly write rho 1 divided by rho 2. That is the actually orientation or the probability. So what does it indicate? That this rho inverse 1, the probability is related to entropy. And you know that entropy is related to measure of randomness, and it also depends upon the structure of the transition state, whether the structure of the transition state is more ordered or less structured. And at that time, one scientist, V.K. I think Lamer, in 1933 published a paper in, I think, Journal of Chemical Society, page number 289. According to the lemma, all these terms are related to, he first time introduced these things, that is entropy of activation and delta H is called enthalpy of activation, and delta G is called free energy of activation. That means that whatever the, suppose this is reactant, this is product, and there is the activated state. So this entropy of activation or enthalpy of activation or free energy of activation is related to the change in entropy or change in enthalpy or change in free energy during this activation process. So in other words, what I can say, that this is the starting point of transition state theory. And three great scientists, Henry Eyring, Polanyi, and M.G. Evans, they actually started to thinking about the structure of the transition state, or how do you calculate the concentration of the activated complex. And the normal collision theory is modified like that, and this probability factor or the proper orientation is nothing but it reflects the change in structure, because when we study the or even we can write like that. Or even I can write like that. It is related to the structure. So, and that is actually related to this transition state and the free energy, right? Free energy of activation. And whatever the changes in free energy of activation, they calculate this, both the things. That is by starting point, this is transition state. So whatever the change in delta G 1, delta G equals 1 like that, and this difference is delta G activation. So this is the actually the modified collision theory. And what is important, that how this energy is distributed, because in collision theory what we do, light on kariye, what we do, that basically what we do, generally what we do, that there must be some collision, and that relative kinetic energy is greater than the threshold energy. But we have not considered the translational energy or the vibrational energy and the rotational energy. So therefore, a modification is required, because in transition state theory, with the help of partition function, because that is very important, with the help of partition function, the transition state theory is developed, because there you have to consider the structural change, what is the change in vibrational motion or translational motion or rotational motion. So I would like to summarize today's modified collision theory, is that collision theory is good, but we have to consider the orientation and the probability factors. And after doing this derivation, it is observed that this probability or the steric factor is based on the entropy of the activation, which is related to enthalpy as well as the free energy. So that is the modified collision theory. Thank you very much.